Interesting question. What's your star sign?
My star sign? Well, I think it's Scorpio. Yeah, what's
Really?
yours? Yeah.
Well, mine is it's right here. It's pies.
I didn't know that was a star sign.
Oh, well, it's got to be, hasn't it? It's got a star.
Oh, that's true. That is so true. But well, I'm trying to be doing something. Maybe doing something now. I was asked to do something.
Oh, don't be silly. You've got to eat a mince pie as well.
Oh, of course. Mince pies are great, but I'm sure there's something else.
No, I think you're just feeling weird because it's not Christmas yet.
I love Christmas. Yeah, we're meant to be doing a video.
Maybe.
Maybe.
Probably on with that.
Yeah.
So, Transformations.
I love mince pies.
It's true. So, there's Transformations 1 and Transformations 2 in our book. I don't know about yours. We're just going to do everything you need to know on transformations in this one video.
Yep, we're going to call this one Transformations. Original, I know.
So up here we've got y equals f of x is drawn like this.
Now, you might not have seen f of x before. That means, it just means a function. In this case, if you know that graph, you'll know that that's just x squared, but it could be anything.
It could be x cubed, it could be x plus 3 minus 2, which is just x plus 1. Maths. But it's just a function, and in this case it is y equals x squared. Now we're going to do a bunch of things to this function, and it's going to change what the graph looks like. Like if we eat too many mince pies, we probably won't look the same.
No, we'd probably look like an amorphous blob if we ate all of them in the world.
We probably would.
So let's not do that.
These are different transformations. These both have plus 5, but one's outside the bracket and one's inside the bracket. This will make sense immediately.
Yes. So, if I draw another x's,
Yep.
this is where stuff's going to happen.
So if we draw this one in black, f of x plus 5. Now, when the plus 5 is outside of the bracket,
It means it's to do with the y half.
and it just goes up 5 units.
So this becomes 5, because originally it was 0.
Yeah, you can draw that. And we're translating, if f of x equals this, f of x plus 5 is going to be this moved, and it's moved up 5 as Triv's well drawn.
Yeah. Go.
So now if we change colour to red for this one underneath it, f of x plus 5, now that's not moved up 5 because the plus 5 is in the brackets instead.
That means it's to do with the x, but because it's to do with the x, it's evil and nasty.
Yep, because everyone's x is evil and nasty.
That's how it works. So because it's evil and nasty, it actually moves minus 5, so it moves 5 in this direction.
Which means it's still going to be the same height, and then it's going to go up just like that.
Yep.
Because again, it's this graph moved this way.
And that is minus 5. So you can think about moving the original point, the origin.
So if the number's held to the x in the brackets, it's to do with the x, and it's going to be nasty.
It is. So, how about this one, Wayne? This one's a bit different. It's outside, but it's not plus or minus, it's times.
And I'm agreeing, I feel like we should be doing something.
Dry cleaning? Got your dry cleaning to do?
I've never dry cleaned anything in my life.
No, I haven't. I think you need water.
Yeah.
So you need to wet clean stuff.
I always wet clean.
I always wet clean.
We're just going with it.
Alright.
So the 5 is outside, it's not held into the bracket, so it's going to be to do with the y. And in fact, every y value is going to be 5 values higher. Every times by 5 values higher, sorry. So this value isn't going to change, because in the y direction it's 0, and 0 times 5 is 0, so it's still going to go through this 0 point.
It is, but what's going to happen is it's going to sort of do this.
Yeah, if this value is 1 unit high along the x, here it's going to be
5.
Yes, if you want to annotate it. And then if 2 was, say, here, that's now going to be 10, so it's going to have shot up a lot more. So it's going to be very, very steep, and it's going to do the same in the negative. It's going to just times everything by 5.
Absolutely. So, we can... That was a good guess, and probably quite a good guess. It's inside, so it was to do with the x.
And it's going to be weird.
So Wayne, I think we can't use red again.
No?
I think we should use purple.
Yeah, that's a good idea. I like purple.
I like purple. Purple's good. Are you sure you haven't took the bins out? Gardening?
Yeah, the garden looks alright.
It looks fine, doesn't it? Yeah.
Bins they're out.
Yeah, so it can't be that. Take them in.
No, not yet. The rest of the street. Let's just get on with the
Alright,
next one.
okay.
So it's 5x, it's in, it's going to be evil, as Triv said. It's not going to stretch 5 out and make it really bloody wide.
No.
It's going to do a fifth. It's going to divide by 5. So every x value, if we say, can I borrow the purple so I'm out of purple?
Okay.
If, we'll do it on this side now, if we're told that this x value along is -1, that x value will now be a fifth of that. It will now be at -1. So it will be at that height at -1
fifth.
So in fact it will look pretty similar to that
It'll look very similar to that one, because instead of being -1, it'll be minus a fifth.
But at the same height as it was before.
Yeah. So there 1, that's minus a fifth, so it is almost identical to our green one. If instead it was a fifth, then it would be really wide.
Yes, because rather than doing a fifth, you're dividing by a fifth, which is the same as timesing by 5.
Absolutely.
Worth mentioning, you can combine some of these, so you could have it times by 5 and added 5, so it will be smaller if it's times by 5 inside the bracket, because it's opposite.
Then it would be 5 up.
So you can combine them. There's a final transformation. These are translations, these are both stretches, should have mentioned that.
Yeah, these are all transformations and these are stretches. This one is to do with mirrors.
Yep. Did we pick Wilfred up from the airport?
No, but he wasn't getting on a plane, so that's okay.
Oh, so he doesn't need to. Okay.
No.
Okay. I don't know, I just feel there's something.
There's definitely something, isn't there? It's not Christmas yet, is it? We have got mince pies, but we don't need to buy presents yet.
No, I don't think so.
I probably do, but...
We'll just keep cracking on. So, reflection with the mirrors and
stuff.
stuff.
The man in the mirror.
So, I'm not going to put up an f of x equals because I don't know what this equals. If we say it looks like this, say, that's the f of x. F of x equals that. And we've been told to draw f of minus x.
So, you should be used to it now. Inside of the bracket is to do with the x. And we've had a spoiler really, it's a reflection.
Yep. So what it's going to do is, if we're told that this maximum point here is, say, 3 units across, 4 units high, so this is 3 and it's at 4 high in the y direction.
You can use it, it's symmetrical to use this.
When it's flipped, yep, it's going to be 4 high. That's not going to change because it's not affecting the y direction because it's the x.
Now won't it be flipped?
No, it's reflected this way.
Okay.
Then it will be at -3, like this.
Oh yeah, sorry.
So it will look something like this. And sort of isn't as evil as the others, I guess. It's not reflected in the x direction, it's actually reflected in the y direction. So it's sort of evil, but sort of makes sense. It depends on your view. To me, it makes sense that it would be flipped this way. This seems more evil, but you might think it's flipped this way, so you might think the evil way is to flip it that way. Just remember, if it's negative x, the y remains unchanged, the x is affected.
Yeah.
So it's flipped.
And this similar thing will happen if it was, say, minus f of x.
Yep. If it's minus f of x, it's going to be the y that changes. So this point will still be in line with 3, this part, but it will be -4 because it's been flipped.
It will basically be upside down.
Yeah, it's just upside down. These points should be exactly the same. I'm just quite a poor drawer. And a final thing to mention, if we have something like a mince pie lid flying across the studio,
Which you probably couldn't see, but trust us, we'll get that for a sec.
we might have something like the sine graph, which happens to look like this. If you're told that that's shifted, if that's f of x, f equals x, what's actually sine x would be how it's expressed.
Yeah.
F equals sine x plus 90, then it means, because it's in with the x, it's in the bracket, it's evil, x's are evil.
Yep, so it goes the wrong way. So it'll end up going this way, so we need a new colour.
Yep.
Say a red.
Every single point.
That's not red.
That's not red. Every single point is going to be moved 90, not just the centre. Although if the centre moves, they all move anyway. But every point will be moved.
So this will be minus 90.
Yep. And when Triv's added on an extra bit here, the reason is the sine graph actually goes on infinitely, and Triv knows that, so he added some on.
And I think
that's transformations. There's still something we're forgetting, isn't there? Did I wash the pots?
I don't think it's that. I think I'm meant to be doing something.
Oh, we had a job, didn't we? Anne gave us that job, but we were too busy joking about M&Ms.
So we needed to
get
them out of here.
Get them out of here! Get out! Get out! Get out!
Oh my God!